Okay, so I had started working through this example before, and I had to cut that video short, so I'm starting this over, but I'm going to just kind of walk through the information I already found. We're trying to graph y equals secant of 2x plus pi over 4 minus 1 in this example. And like we saw previously, to graph a secant function, what you want to do is actually graph the related cosine function, meaning the cosine function that has the same a, b, c, and d as this secant function here. So based on what we have here, the amplitude would be 1, midline would be y equals -1, period, remember we're talking about cosine, so the period of cosine is normally 2 pi. The period would be 2 pi over 2, which is just pi. Phase shift, c over b. Because of the plus here, c is actually -pi over 4, divided by 2, that's -pi over 8. So I plotted my -pi over 8 here, used my period, which was pi, to add -pi over 8 plus pi. That gives me 7 pi over 8. So here's the interval that we're going to graph over. Midline is -1, amplitude is 1. So that gave me -1 here. I'm going to sketch my midline. And then we have a maximum of 0, minimum of -2. So remember, the function here is cosine. Cosine starts at a maximum. Oh, you know what? I didn't give the rest of my x values. Let's do that first. So we do the averaging technique. I'm going to add these up. -pi over 8 plus 7 pi over 8 is 6 pi over 8. Half of that would be 3 pi over 8, which I'm going to put roughly here. Okay. 3 pi over 8 plus 7 pi over 8 is 10 pi over 8. Half of that is 5 pi over 8. And then you might be seeing kind of a pattern in the numbers here. We should end up with a pi over 8 here. This is definitely not equally spaced. Let me actually do that a little bit better. -pi over 8. Still not perfect, but that's good enough. Cosine. It's going to start at a maximum. Go to our midline. Minimum, midline, maximum. Okay? Now I'm going to put the cosine curve through these points, but I'm going to do it in kind of like a dashed line, because remember, this cosine graph is not the actual graph of the function we were given. We're using it as a guide. So I'm going to, if you're using pencil, you could just do it really light, or pen, you could do dashed like I did. Next up, we need some asymptotes here. So again, going back to the original secant graph, those asymptotes, those red dashed lines, appeared anywhere the cosine function crossed the x-axis. But it's not really the fact that it's the x-axis that's important. It's the fact that that's the midline for our cosine function. In this case, our midline is changed. It's at y equals -1. And I have 2 points that have intersected that midline. So I'm going to put asymptotes through those points. From here, the graph is really straightforward. Remember, at this minimum value, I should have a shared point and then a U shape kind of opening downward, approaching those asymptotes. From this maximum, I should have a shared point, and because I'm only graphing within this first interval, I'm not going to show the entire U shape. I'll just do this left half of it. Similarly, over here, I'm going to get the right half of a U shape. Okay? So that would be the secant graph. And notice 99% of the work is just graphing the cosine function. If you know how to do that, the secant is pretty much automatic from there. Similar one right here, cosecant function. I want to graph 3 cosecant of 1/4 x plus 5. So I get the same information, amplitude, midline, period, phase shift. Okay. No reflection on this one. What's the amplitude? I can see that it would be 3. Midline, I could see it would be y equals 5. Period is 2 pi over 1/4. 2 pi over 1/4, which is equal to 8 pi. My phase shift, well, there's no, the c in this case is 0, so the phase shift will also be 0. Okay? So the phase shift is 0, period is 8 pi. I can see that I really just need space to the right of my y-axis in this case. Actually, I should have given myself more space above my x-axis, but that's okay. Midline is at 5. And from there, I need to go up 3 and down 3 because of my amplitude. So that's going to take me to 2 and 8. Okay, with a midline right here. Now, phase shift is 0, so that means our left endpoint of our interval is going to start at the origin. Period is 8 pi, so I add 8 pi to 0, and that's just going to take me to 8 pi. Now this is convenient because averaging these intervals is going to be really straightforward. 0 plus 8 pi is 8 pi, half of that is 4 pi. It should be easy to see that this will be 2 pi and this will be 6 pi. Okay? Now remember, the cosecant function is the reciprocal of sine, so we're graphing a sine function first. Sine starts at the midline, goes to a maximum, midline, minimum, midline. And like before, we graph with this sort of dashed curve here. Okay, having done that, I put asymptotes through any points of intersection between that sine curve and the midline. There's 3 of them in this case. One of them is the y-axis, so I'm not going to put a new line through that. One of them shows up here. One of them shows up here. Now, I have a maximum here, so I'm going to have one of those U shapes that approaches my asymptotes. And I have a minimum here, an upside down U shape approaching those asymptotes. And that would be my cosecant graph. Okay, I'm going through these fairly quickly, and again, that's just because most of the work is identical to what we did in 8.1, when we've already seen several examples of those. So it's kind of more of the same, just with one extra step at the very end. Secant now, just like we did for the first example on this page, it's like a cosine function. We need amplitude, we need midline, we need period, and we need phase shift. What's the amplitude for this? Absolute value of -2, which is 2. Midline. There's a 0 for my d here, so I'm going to write y equals 0. Period. What's the period of this graph? 2 pi over 2. Here the pi's will cancel, and this is going to end up equaling 4 in the end. And then finally, what's my phase shift? C over b. That's pi over 3 over pi over 2. The pi's will cancel. This comes out to 2/3. Okay? So again, a lot of fractions to worry about. One extra thing in this graph, we see the minus out here, which implies a reflection. So putting all of this together, midline is 0, amplitude is 2. I can see that my phase shift is positive and the period is 4. I'm going to need a lot of space to the right of my y-axis this time. So let's get some of this down. The midline is the x-axis because it's y equals 0, so I'm not going to draw that. Amplitude is 2, so I'm going to go up 2, down 2. Phase shift is 2/3, so we're going to move over here to 2/3. And then the period is 4, which I have to add to that. Remember, we're working with common denominators of 3 here, so 4 is the same thing as 12/3, plus 2/3 would be 14/3. Then we start doing that averaging thing. 2/3 plus 14/3 is 16/3. Half of that would be 8/3. 2/3 plus 8/3 is 10/3. Half of that would be 5/3. Finally, 8/3 plus 14/3 would be 22/3. Half of that is 11/3. Okay, so those would be the x-axis labels that we needed. Now I have all the labels, we can start graphing our function. It's a cosine function, but it's a reflected one. So instead of starting at a maximum, we start at a minimum. Minimum, midline, maximum, midline, minimum. And we put a curve through those. This dashed curve because it's not the thing that we actually want to graph. Okay, this time because the midline is the x-axis, I'm looking for x-intercepts to get my asymptotes. So I get one here at 5/3 and one over here at 11/3. And then from there, look for those shared points. So for example, at this maximum, we have that upward U shape. and at these minimum values we'll get these downward U shapes, and I'm only graphing half of those because the rest of the U would go outside of the interval that we're looking at. Okay, that's it for 8.2.